All right, mathletes, here we go. It's ratios and proportions with similar triangles and similar polygons. First thing we have to talk about is what is a ratio. Ratio is a comparison of two quantities by division. There's three ways that we can write ratios. We can just write it out in words, that the ratio of A to B. Well, that can be translated using a semicolon where you have ratios A to B. A lot of times odds for gaming and things like that is used in that format. And then a lot of times in mathematics, we're going to use the ratio of A to B written as a division, and that's going to be a lot easier for us to manipulate algebraically. So this will be our go-to for when we're doing algebra on things, but we got to make sure that we understand these two. So if we're given it in these two forms, we can then put it into our algebra form. So ratios, a lot of times we're going to talk about with our similarity and dilation. So when we shrink and grow things, we want to make sure they shrink and grow in a proper ratio. We want the width to grow in the same ratio as the height. If they don't go into the same height and ratio as one, you can get images that are distorted like this or distorted this way. So when you grow an image, you want to make sure they grow proportionally so that they're the same. So for instance, if we have a photo that's a 5 by 6 inch photo and we want to blow it up because it's our favorite cat in a orange photo and put it in our wall and make it a poster, we can go ahead and figure out, well, if we want this to be 20 inches tall and 24 inches, okay, the ratio of the width of the photo to the poster. So what we want to do is, so the width is down here, that's 24. And then to the width of our photo is 6. So we can see that when we simplify this 24 to 6, that's a ratio of 4 to 1. And to make sure that that proportion is held, we wanted to make sure that our not only our width but our height grew in that same proportion. And we can see that 20 over 5 is going to reduce down to a proportion of 4 to 1 so that we didn't get any distortion there. So our scale factor here is going to be 4 to 1 from our poster to our photo. All right. So on top of that, talking about proportions. Proportions is when we're going to, a statement that contains two ratios that are equal. They're going to be written in two formats. We're going to prefer the proportion on the left side opposed to the right side because it's going to be a lot easier to work algebraically. But again, if we're given it in this format, we're going to want to be able to translate it over here. Just recognize that the first letter is our numerator and the B is our denominator. You can kind of think of these as slashes here, and that's going to be our dividing sign, and then C to D can be C over D as well. So determine if each of the following pairs of ratios are equal. So again, I'm going to want to translate them. If they're in colons, I want to translate them into a proportion using division. So 1 to 2. Is this, so I'm questioning if this is equal to 5 to 10. Well, anytime you want to see if a proportion is equal, reduce both of them as low as they go. Well, 5 to 10, they're both divisible by 5, so I can do 5 times 1 over 5 times 2. Something divided by itself simplifies to 1. So then I can see that this reduces to 1 to 2, and the proportion 1 to 2 is equal to the proportion of 1 to 2. So therefore, 1 to 2 is equal to 5 to 10. So yes, those ratios are equal. When I look at 2, if I have 5 over 3 is equal to 3 over 5, they can't be reduced, and they're not equal. I have 5s up top and a 3 up top, and vice versa on the denominator. So this is not going to be equal. Okay. So then again on the third one, to determine if these are equal, we got to reduce them. So the one on the 10 and 15, I see that they're both divisible by 5. So I can do 5 times 2 over 5 times 3. 5's cancel out to be, or simplify to be 1. So I get 2/3 here. And 18 and 27. They both have a factor of 9 that can go into them. And I can do 2 times 9 over 3 times 9. 9 simplify to a 1. And I can see that I have now the proportion of 2/3 is equal to 2/3. Well, yes, that is the same. So some properties of proportions that we want to talk about here is some resources for us to help solve these proportions out if we have a missing value there. So one is going to be doing cross multiplication. So if we did A times D, we would have that over there on the left side, and we can do B times C, and we'll have that over on the right side. The nice thing about that is we eliminate our fractions, and we'll probably feel a lot more comfortable solving out expressions if we don't have anything in our denominator. Another principle that we can use is understanding that as long as our rows and columns are matched up, that A and C correlate and B and D correlate, and A and B and C and D, we can go ahead and flip those. So if we flip A and B, we would get BA, and we flip CD, we'd get DC. So we still have the relationships that C and D are correlated, and B and D are correlated, and A and C are correlated, along with A and B. So using that same kind of idea that we can interchange rows and columns as long as we keep that pairing, we see here, erase that. If we look here, AC, instead of them being across from each other, we can go ahead and put them over each other. And BD, instead of them being across from each other, we can put them over each other. But notice that we have to make sure that this AB relationship, which was once a column relationship, is now a row relationship with AB, and then CD relationship is along the lines there. We want to make sure we don't get into any cross things and try and do A over D is equal to B over C. Things like that, we just can't randomly throw them around because A, D, they don't correlate up here. You can see that they're opposite of each other. So we don't want to do things like that. But these three properties are going to be useful when trying to set up proportions and solving our proportions out. So if we have this relationship that x over y equals 5, 6, we want to be able to use these properties of proportions to write things out. So on number 1, I noticed that 6 and x were cross multiplied. So if I multiplied 6 times x, I can cross multiply here, and 6x is going to be equal to 5y. Okay. So for number 2, I can recognize that xy looks very similar to this left side, but we flipped it here. So what was on our denominator became our numerator, and vice versa. So we want to do the same thing to our right side. So we're going to flip it, and we're going to get 6 over 5. Okay. Again, notice that 6 lines up with y, 5 lines up with x, but we just reciprocated both left and right side. Okay, number 3, so if we have x over 5, so now we're kind of interchanging our, which was a row, into being a column. So then if x over 5 is there, this row is going to be our new column, y over 6. And I know y has to go on top because it's paired up here, so we have to have that relationship there. Okay. So to solve these proportions, typically the first strategy I'm going to suggest doing is trying to do our cross multiplying here. So When you cross multiply, we're multiplying by our denominators on both sides. So here we do 8 times x. We get 8x is equal to 6 times 12, which is 72. And at this point, just do some Algebra 1 skills. So I'm going to divide both sides by x. I'm going to get x is equal to 9. At number 2, again, I'm going to employ the same strategy. And I'm going to do y plus 3 times 4. And we got to make sure when you do 4, we multiply by the entire quantity y plus 3. So I want to see these parentheses here anytime we have multiple things in our proportion. So then if that is our cross multiplication there, this is going to be equal to 8 times y. At this point, I'm going to recognize that this is just going to be a multiple step equation. So first I'm going to distribute the 4 to both of these, and I get 4y plus 12 equals 8y. Since I'm trying to get y by itself and I have some y's on the left, some y's on the right, I want to collect my like terms. So I'm going to move this over here by subtracting the smaller one over to the other side so I can keep positive values. And then I'm going to get 12 on the left side is equal to 4y. My last step is to divide both sides by 4, and I'm going to get y is equal to 3. All right, our last one, we're going to do 5 times 3 is equal to z times 20. And again, simplify my left, I get 15 is equal to 20z. Trying to get z by itself, I'm going to divide that out. Divide by 20, divide by 20, and I get z is equal to 15 over 20, and reduce anytime where possible. Both of these are divisible by 5, so I can do 5 times 3 over 5 times 4. This simplifies to be 1, and 1 times 3/4 is 3/4. Okay, so that's how we'll try and go about solving our proportions. So some other times that proportions come in handy is when we're talking about scale factors. The scale is the ratio of any length in a scale drawing to the corresponding actual length. So you'll see this in maps, you'll see it in technical drawings. If you're putting instructions together on how to build your desk, it's not going to give you instructions that are the size of your desk. Things are going to be scaled down. So what we want to do is be able to set up a proportion and solve for one, if we're trying to figure out what an actual distance is and we're given the scale factor and we want to know what that distance is in our drawing, and be able to go back and forth. So our big key on this drawing on the right is we have a scale that is 1 inch is equal to 16 feet. So what I'm going to do is I'm going to set that up as 1 inch to 16 feet. Now the key is to make sure we line things up appropriately. Just like when we were looking at a relationship. So I know that if this is 1 inch on the top, I want to make sure the top is in inches and it's talking about our drawing. And on the bottom, the 16 feet, this is in feet and it's the actual dimensions. So as I'm setting this equal to, and I see on this it says an inch ruler shows that the length equals 7/8. So if I take a ruler and this is equal to 7/8 of an inch on your drawing, okay, again I see over here that my drawing dimensions should be on the top. So I'm going to have 7/8 over here, inches. And it wants to find the actual length of the bedroom. So the actual is my unknown, my x in feet. Okay, so if I go ahead and now that I have my proportions set up, I can go ahead and cross multiply here. So I'm going to see that 1 times x is going to be x, and that 7/8 times 16 is going to be on the other side of my equal sign. So I got 16 times 7/8. All right, so I need to simplify this so I can think of this as just 16 times 7/8. What's nice is I can see that 16 is divisible by 8, so I can do 16 divided by 8 times 7. 16 divided by 8 is 2 times 7 equals 14. So notice this is the x here, it's 14 feet. So that this length of this bedroom is actually 14 feet, has a length of 14 feet. So I have to be able to use these scale factors to help us find actual measurements in real life opposed to from their scale drawings. So that concludes our notes on ratios and proportions. Thanks a lot.